Hello everyone, today in this tutorial I will discuss about third semester Midsem paper of numerical analysis. Here the first question is about fixed point theorem, and using this theorem we have to solve two problems. So let's first understand about existence and uniqueness in fixed point of function. Following theorem gives a sufficient condition for the existence and uniqueness of the fixed point function. So first one is if G belongs to a G continuous function and belongs to A to B, and G of X is belongs to A to B for all X belongs to A to B, then G has at least one fixed point in A to B. Theorem states about existence of FPT. Second one is if in addition G dash X exists on A to B and a positive constant K less than is equal to 1 exist with G dash mod of G dash X less than equal to K for all X belongs to A to B. Now what we'll do is then there is exactly one fixed point in A to B. Now let's start the proof. I will first prove existence theorem. if g of a is equal to a or g of b is equal to b, then g has a fixed point, g has a fixed point at an end point. If not, like we have to find a fixed point between a to b, right? So if not, then g dash a should be greater than a and g dash b should less than b. So now let's assume a function h of x, which is defined as g of x minus x, which is continuous in a to b. Now with ha will be g of a minus a, which is greater than 0, then g of a is greater than a and h of b will be less than 0. H of b is equal to g of b minus b, which is less than 0, then g of b will be less than b, right? We know that from IVT, intermediate value theorem, there exists p belongs to a comma b, for which h of p is equals to 0. So p will be fixed point of g, because hp is g of p minus p, which is equal to 0, which implies g of p is equals to p. So we proved existence theorem. Now we'll go, suppose in addition that g mod of g dash x is less than equal to k and p and q are both fixed point in a to b. If p is not equal to q, then mean value theorem implies that a number n exists between p and q and hence between A to B with like g of p minus p g of p minus g of q upon p minus q is equal to g dash n. Now g of p minus g of q is equal to g dash n into p minus q. Taking both side mod, we have mod of g of p minus g of q mod of g dash n into mod of p minus q, which is less than or equal to k into p minus q, and it is given that p and q are fixed points. It means g of p minus p is equal to g of q minus q is equal to 0. So now take this g of q in left side and p on right side. So g of p minus g of q will be equal to p minus q, and take both side mod. Take mod both side. So here mod of g minus p minus g of q now here mod of g of p minus g of q is equals to mod of p minus q. Let's it is equation second and this equation is first. So, using first and second, mod of p minus q is equal to mod of g of p minus g of q, which is equal to less than or equal to p minus q. This and this will got cancel. Here k is greater than or equals to 1, which is a contradiction, because in theorem it is given that k is less than 1, so it is not possible, right? Now let's discuss question number second, which is saying that g of x is equals to x square minus 1 on 3 has a unique fixed point in minus 1 to 1. Hence find the approximate root of f of x is equal to x square minus 3x minus 1 is equal to 0, and the answer should be correct up to 3 decimal places. Has a unique fixed point in -1 to 1. Now consider g of x is equals to x, and we will start with an initial guess x naught and compute and using successive approximation we have xn plus 1 is equal to g of xn, which is equals to xn square minus 1 by 3, right, for n greater than or equal to 0. So now we'll make an iterative table and we'll continue going till the answer should correct up to 3 decimal places. So now guys, let x naught is equals to -1, then n is equal to 0, xn will be x naught, and it is -1. Now for n is equals to 1, it will be x1, and after calculating xn will be minus 0.33. If n will be 2, then xn will be x2, and which is equals to minus 0.2962. If n will be 3, then xn will be x3, which is equals to minus 0.3040. If n will be 4, then xn will be x4, and its value is minus 0.3025. If n will be 5, then xn will be x5, and its value is 0.3028. And guys, see here, up to 3 decimal the value is same, so the answer will be minus 0.302. Now in third question, we have to prove g of x does not satisfy the FPT in 3 to 4. Now using uniqueness theorem, we have mod of g dash x should be less than equal to k, and k is less than equal to 1. So guys, here g of x is equals to x square minus 1 by 3. Differentiate it, so it will be g dash x is equal to 2x by 3. Mod of g dash x will be 2 by 3 into mod of x, and for all x belongs to 3 to 4, mod of g dash x will be greater than 1 for sure. So we can say that this function g of x does not satisfy the fixed point theorem in 3 to 4. So guys, if you understood this question, then hit the like button, consider subscribing. Thank you.